Hey guys, this is the editorial for problem 4 of FBISD UIL Practice 4 City Model, and today I'll just be going over the solution and we'll be coding up a solution as well, and I'll make sure to link that in the description. So let's get started. So if you guys have already read the problem, I'm just going to explain it really quickly. We're given a graph with nodes numbered 1 through n and some edges, and given some queries Q, we want to find how many nodes are within a distance of Q from node 1. So we're just counting the number of nodes that are within distance of node 1. So now before I continue, I just want to clarify something. In our program, instead of using nodes as numbered 1 through n, we're going to instead do it from 0 through n minus 1. And that'll just make it easier for the array indexing. So from now on, just forget that they're numbered 1 through n, and instead they're numbered 0 through n minus 1. So let's go into an example so you can better understand the problem. And what I've done is I've taken the graph we already have here and converted it into the 0 to n minus 1. So this will be the node that we are counting distances from. So let's start by getting a query Q of 0. So we want to find all nodes that are within a distance of 0 from node 0. And that would just be 0 itself. So we would just print the answer 1 for that case. Now if our Q was equal to 1, we're trying to find all nodes that are within a distance of 1 from node 0. So we would then have node 1 and node 2. These are within a distance of 1. So that total, including 0, would be 3. Now if our query Q is equal to 2, we would then include 4 and 3, because these are within a distance of 2 of node 0. So our total would be 5 then. So now that you guys have the example, let's go into how to solve the problem. So first things first, you guys probably noted that when we start at node 0 and then we traverse the 1 and 2 and then we go to 4 and 3, the first thing that comes to mind is probably BFS, our breadth first search. And if you guys don't know what BFS is, I highly recommend looking it up and looking at the code for that, because that's essentially what we'll be doing in this problem. But if I want to, I'll just quickly explain it so hopefully you can get an idea of what's going on. So we start at node 0, then we're going to look at its immediate neighbors, 1 and 2, and we'll go to these nodes. Then we look at the neighbors of those nodes. So 2 has no neighbors, so we're done traversing that side of the graph. Now 1 still has neighbors, so we're going to traverse and go to 4 and go to 3. And after we've gotten to 4 and 3, there are no new neighbors to traverse, so we've officially just traversed the whole graph, starting from node 0. You probably notice 5 right here, and 5 is honestly kind of useless because it's not connected to the graph. There's no path between 0 and 5, so we don't really worry about 5 at all. So now that you guys have an idea of what BFS is, let's actually start doing the problem. So how it works is that we're gonna create an array that stores distances for us. And now in the question, I know it says it wants the distance of within Q, but we're gonna use this as immediate distances. So like these are the exact distances. And then we're going to do a cumulative sum later to sum up the within distances. So this array right here will store the number of unique nodes that are at a distance from node 0. So let's go ahead and do that. So at position 0, we're going to store all the nodes that are at a distance of 0 from node 0. So we know right off the bat that this is going to be 1 every time, because only node 0 is within a distance of 0 of itself. So that will initialize early. Now this will be unique nodes that are at a distance of 1 from node 0. Now we know from our example that nodes 1 and nodes 2, both of these are at a distance of 1. So we'll have 2 there. And then nodes 3 and nodes 4 will be a distance of 2. So that will go here. So how this works, however, in our programming is that we're going to start by doing a BFS at 0. So we're going to start at 0. Now we already know 0 is within 0 of node 0, so this will be initialized as 1. Now our BFS will take us to node 1 and node 2. And what we're going to do is we're going to store a temporary current distance value. And every time we go to a new stage of BFS, we're going to increment this current distance by 1. So initially current distance will be equal to 1, and we'll find node 1 and node 2. And that's two new nodes, so our array at position 1 will get incremented twice, and that's how we'll get to 2. After we finish this level of BFS, we're going to go one level further. So what we're going to do first is increment that current distance. So now our current distance is equal to 2. And now we've already finished traversing 1, 2, and 0. So now we're going to get 4 and 3. And that means we're going to increment our position 2 twice, because we got 2 more unique nodes. So that's how we'll get 2 here. So if you guys kind of see what I'm doing here, is that we're doing a BFS. Every time we go one level deeper into the graph, we're going to just increment this current distance counter, and we'll just continue doing that and until we traverse the whole graph, and then we'll be done. So let's go ahead and take it to the coding now. So first things first, we need to somehow store the graph, and for that we're going to use an adjacency matrix. And what that is really is, in this case, we're going to use an array of array lists, and at position 0 of the array, we're going to store all the nodes that are directly adjacent to node 0. So if we look at this example, at node 0, 1 and 2 are directly adjacent to it. Then at position 1 of the array, nodes 0, 3, and 4 are directly adjacent to it. And we'll just continue creating it like that. That'll make our BFS a lot easier. So let's go ahead and start. So we're gonna go ahead and do that. Then we're gonna start by creating our adjacency array of lists. So this. Now we're going to initialize, because we need to initialize every array list to an empty array list. So we're going to go ahead and do that. Now it's time to load the edges in. So we're going to go ahead and do that. So and remember that we're treating the nodes as 0 to n-1. So right as we're loading them, we're just going to go ahead and decrease them by 1. This will just make it a lot easier for us. Now it's time to add. In this case, we're adding the v to the adjacency list of u, and then we're going to do the vice versa. So we're going to add whoops. Okay, now we have our adjacency matrix loaded in, so it's time to do the problem. So as I was saying earlier, we're going to do a distance counts array, and we're going to make it n+1 because there may be nodes at a distance n. Now, as I was also mentioning earlier, we want to initialize the first part. We want to initialize the first element of this array as 1, because we know that the only node that's a distance of 0, of node 0, is just itself. So it's alright if we just initialize this as 1. Now, this variable right here is going to be our current distance tracker. So we're going to start it at 1 because that's the first level of BFS. And then, like traditional BFS, we have to store a boolean of visited. So that way we don't run into a problem where we just keep on looping in a cycle. We want to always discover new nodes, and if we've already seen the node before, then we just want to go ahead and skip that. So we're going to initialize the first part as being true, the first element, because we're starting at node 0. And now we'll just go ahead and declare our BFS list. Now that we've got that started, what we're going to do is we're going to add our node 0 to BFS, and we will commence BFS. So this is all traditional. If you've seen BFS's algorithm before, nothing different. We're going to continue this while loop on the outside while BFS is not empty. And what this guarantees is that we keep on doing the BFS until this BFS array list has no new neighbors to explore. This will only be empty once we've discovered everything we already want to discover. So by the time this is empty, we've already traversed everything that's connected to node 0. So we're going to do a temp array list, and this is what we'll reassign BFS to once we're done with one level. Now, what we're going to do, we're going to loop through the new neighboring, like inside the BFS is the nodes we want to explore. So we're going to go through those. Sorry. And then we're going to look through the adjacency matrix of this node U. So we're going to go from integer v through adjacency U. And now we need to make sure that we're not going through a node we've already been through, so that now we're going to make sure that it's not been visited before. So once we've got into this node that we're going to visit, we're going to go ahead and mark it as we visited already. Now what we want to do is increment that distance counts by 1. Basically that's this stage right here, like right here. What we're doing here then is that once we've got into node 1 and node 2, we've discovered that, okay, this node 1 is a distance 1 from 0. So we're going to go into our distance counts and increment that position 1 by 1. That means we found a new unique node. So we're going to do distance counts of the current distance, and we're going to increment that. Then what we're going to do is we're going to add v to temp because we want to explore the neighbors of v in the next round of BFS. Alright, so now that we've done all of that, we want to just reassign temp to BFS because temp has all of the new neighbors that we want to explore. And then what we're going to do, current distance plus plus, because after we finish this, after we finished one loop of BFS, we're going to go one level deeper into the graph. So we want to increment current distance by 1. Alright, that concludes the BFS part of it. So now all that's left is just formulating the answer. So as I was saying before, this array that we have here is only storing the number of unique nodes that are at a distance of exactly 0, 1, 2, etc. Now we want to do a cumulative distance because we're trying to find the nodes that are within the distance of the query. So that will be right here. We can go ahead and initialize the first element to be equal to the first element of distance counts, obviously the 0. This is the one that's at a distance 0. Now for int I, I'm going to start at 1, I less than I plus plus. So cumulative distance of I is equal to cumulative distances of I minus 1 plus distance counts. So as you can see here, this is just doing a cumulative sum based off of the array of distance counts. So that way we can just pre-compute all the answers and keep it in this cumulative distance array. Now that we can process the queries, we're going to go ahead and do that. So D is going to be the individual query. And now that we've gotten D and we've already pre-computed all our answers, we just need to go ahead and print them out. D. So that should conclude it. Let's go ahead and run it on the sample. I spelled int wrong. Alright, runs on the sample input, and then we'll go ahead and submit it. Pass test case 0, and all of them. Alright, thanks so much. Make sure to smash the like and subscribe button, and just remember we're going to link the problem solution in the description below, so don't worry about that. And thank you.